Hi folks, welcome back. I hope you're all doing well. So by now we've seen that large language models, LLMs, are pretty decent at generating code from an English language description, but they don't always get it right. And you might have seen this pattern where you ask ChatGPT or some other LLM to generate code, and if it gets it wrong, you iterate on it. You give it a new prompt which tells the LLM what went wrong, what broke, and the LLM can use that additional context to generate better subsequent replies. And that iterative debugging pattern is what the authors are exploring a bit more rigorously in this paper. They call it, aptly enough, self-debugging, and they liken it to the rubber duck debugging that programmers will often do, only this time you're using the LLM as the rubber duck. The basic idea is to teach the LLM to debug its own predicted code by asking it to give you not just the code, but also an explanation of what the code is doing and predict some form of feedback. It could be as simple as whether the code is correct or not. And you set this up via a few short prompt before you present your own problem to it. This diagram shows the overall flow where the model is predicting not just code but also an explanation and some feedback. But then you can iterate on it. You can actually execute the code that the LLM predicts, and if it breaks, you can give that feedback back to the LLM in subsequent prompts. And what the authors found is that usually will make the LLM generate better code the next time round. Let's look at a concrete example of how this might work. This set of prompts is looking at a task where you're trying to translate C++ programs into Python. And we have three versions of this prompting scheme. One with simple feedback, where you simply tell the LLM whether the predicted code was correct or not. And the way you would set it up is, and this is omitted here for brevity, you would set up a few short prompt where you provide many examples of C++ programs with their Python translations, and then you would present your C++. In all these diagrams, the left aligned things are predictions by the LLM, and the right aligned things are inputs provided by you. And so once it has predicted some Python for the C++ you gave it, you can then iterate on the prompt. You can give it some simple feedback on whether it was correct or not, and it would revise its prediction. And you could keep doing this until you were satisfied. However, you can improve the quality of the feedback. In addition to just simple feedback, you could give it unit test feedback. So if the predicted Python didn't pass some of a set of unit tests, you could tell it what the failure messages of the breaking unit tests were. And to add one more layer, you could even ask the LLM to predict not just Python, but also explanations of the code that it was generating, and then iterate the prompt based on the prediction. And here are some benchmarks from this kind of prompting. The task we just looked at, which was translating C++ to Python, on the baseline, which is simply using the Codex LLM, the accuracy was 80.4. And here you can see that increasing the levels of feedback results in subsequent increases in the overall accuracy. So just simple feedback gets it up to 89%. If you add unit test feedback, you get almost 92%. And if you combine them, if you provide unit test feedback and an explanation, you get 92.5. They tried another benchmark, which was generating SQL from English language problem descriptions, and found similar results over there, though the gains are somewhat smaller. They see about a 3-point gain going from the simple Codex model to feedback in the prompt with an explanation and with simple correctness feedback. So that was a quick look at a paper that shows with some benchmarks that yes, indeed, you can get LLMs when generating code to improve their replies by giving them feedback on the code that they have produced. Essentially, you can ask the LLM to debug its own predicted code. And this results in small but noticeable gains in some of the code prediction benchmarks that they ran. And I think that's borne out by the anecdotal experience that a lot of programmers have when using these LLMs for programming. I hope you enjoyed that. And if you like content like this, where I cover computer science papers, and lately I've been looking at a lot of papers related to LLMs, please like this video, please subscribe, and I will see you next time. Thank you.